Alright, assalamualaikum and good very evening to all the lecturer, especially Dr. Narizam. Okay, I would like to introduce our group, which is we from group 6. The topic that we choose is topic 1, which is hydroelectric power plants in Malaysia. Okay, for the introduction, hydroelectric power emerged as a key participant in the worldwide search for sustainable and renewable energy solution, making a sustainable contribution to the shift to cleaner electricity sources, possessing a variety of geographical characteristics. Malaysia is leading this movement. The focus is on the potential and problem that came with using nature river kinetic energy to further the country's sustainable development goals. The story that follow explain the dynamic interaction that occur between hydroelectric power, the Malaysia terrain, environmental factor, and the policies that are driving the development of this essential energy source. Alright, for the objective in this case study of thermodynamic, for first one that we get is educate on hydroelectric power plant operation, which is mean to provide a clear comprehensive explanation of the operation of hydroelectric power plants, ensuring that readers gain an in-depth understanding of the processes involved in converting water's kinetic energy to electricity. Okay, for the second one is focus on Malaysian context. It's mean to contextualize the discussion within the Malaysia setting, offering specific information about hydroelectric power plant in the country. This include details on the major project, their capacities, and their roles in Malaysia in energy infrastructure. For the third one, is highlight technological features uh, to emphasize the technological features of hydroelectric power plant, detailing this role of intake structure. And the fourth one is provide insight into Malaysian hydroelectric project. It's mean uh, to offer information on hydroelectric power plant in Malaysia, such as we have Kenyedam in Terengganu, and so on. Alright, thank you. Alright, the literature review that we get from this case study, which is as you can see, the picture of impounded hydroelectric. Okay, this hydroelectric or this plant generates more than 30 megawatts of power. There are two major of types of hydroelectricity: impounded type and division type. And impounded hydroelectricity, water released from the reservoir flows and through a turbine spin it, which is turn activate a generator to produce electricity. This water may be released either to meet changing electricity needs or to maintain a constant reservoir level. Alright, thank you. Alright, for the application that involve in this case study uh, at hydroelectric power plant, as we can see the picture, this station attached to the outlet of pressure tunnel and located at downstream of area dam. This section consists of main hydropower operation, machine, turbine, and generator, and office complex. There are four turbines with 20 wick gates at each turbine to control the flow of water from upstream and downstream. Turbine generally convert the energy of water falling into mechanical energy. The continuous power station is about 165 mega power, 160 megawatt, and the average annual energy output is 1 1600 gigawatt per hour.
Assalamualaikum. My name is Muhammad Anwar Aziz bin Muhammad Yusof. My part is benefit to the community. So there are a lot of benefit about hydroelectric power plant in Malaysia. to community. So the first one is educational opportunities. School and universities may collaborate with the power plant for educational program relate to renewable energy, environmental, conservation, and engineering. So the second one is renewable energy generation. The communities can reduce their dependence on non-renewable energy. So the third one is job creation. The planning, construction and maintenance of a hydroelectric power plant in Malaysia will create a lot of job opportunity with the community. Okay, for the second point is pros and cons. So the first advantage of the hydroelectric power plant is renewable energy source. Hydroelectric power is a renewable energy source relying on the natural flow of water which is replenished through rainfall and snowmelt. So the second one is long life cycle and low operating cost. Hydroelectric facilities have a long operational life with relatively low operating costs. Once the initial infrastructure is in place, making them cost effective in the long run. So the third one is stable base load power. Hydroelectric plant can serve as base load power source, providing a stable and continuous supply of electricity which is essential for meeting the constant demonstration for power. And for the disadvantage of hydroelectric power plant is environmental impact, ecosystem disruption, geography limitation. So for environmental impact, the construction of dams and reservoir for hydroelectric project can lead to significant environmental impact, including habitat disruption, alter water flow, and displacement of local communities. And the second one is ecosystem disruption. The ecosystem of the river due to the construction of dams can disrupt aquatic habitat and migration pattern of fish, affecting biodiversity in the surrounding areas. So the third one is geography limitation. Hydroelectric power is dependent on suitable geographic condition with access to flowing water, limiting its applicability to a specific region and country.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Azmin. So I want to continue about formulation and calculation. Okay, so for the formulation, power is the rate of producing energy. Power is measured in watts or kilowatts. Energy is what is used to do work and is measured in kilowatt hours or megawatt hours. In simple terms, the maximum hydropower output is entirely dependent on how much heat and flow is available at the site. So a tiny micro hydro system might produce just 2 kilowatt, whereas a large utility scale hydro system could easily produce hundreds of megawatts. Okay, so this is a formula to calculate for the dam. P equals to M times G times H net times mu. So for the P is power in watt, for the M is mass flow rate, for the G is gravity 9.81, for the mu the product of all of the component efficiencies which are normally the turbine, drive system and generator. So for the last H net is the net head, the gross head physically measured at the site, less any head losses. To keep this same simple head losses can be assumed to be 10%. So H net equals to H gross times 0.9. Okay, now we continue to the Kenya Dam. So this is an example and information about Kenya Dam. So the name is Kenyah Sultan Mahmud Hydroelectric Power Project Malaysia. It is operated by TNB, which is Tenaga Nasional Berhad Malaysia. Main reservoir is Kenyal Reservoir, capacity 400 megawatts, catchment area 2,600 square kilometers. Height of the dam is 155 meter. Trace length of the dam is 800 meter. Annual generation is 1,006 gigawatt hours. So for the flow rate is 15.20 million cubic meters. For the type of dam is embankment with rock fill. So for the type of turbine is from franchise. Type of power grid, regional grid. For the type of plant is dam on a river with reservoir. Okay, now we continue to the basic calculation for Kenya Dam. Basically, is a basic calculation. So for the calculation is power equals to head times flow times efficiency over 11.8. So for the power is the electric power in kilowatts or watts. 1 kilowatts equals 1000 watts. For the head is the distance the waterfall measured in feet. For the flow is the amount of water flowing measured in cubic feet per second. For the efficiency is how well the turbine and generator convert the power of falling water into electric power. This can range from 60% for other poorly maintained hydropower plants to 90% for never well maintained plants. So for the last is 11.8, which is index that converts units of feet and seconds into kilowatt. So that's all from me. Thank you. Assalamualaikum.
So for the conclusion, hydroelectric power is a cornerstone of Malaysia energy industry, crucial for achieving renewable energy capacity and reducing on non-renewable source. Initiatives like the Kenya Dam exemplary Malaysia commitment to a diverse energy portfolio. Addressing environmental concern through analysis and sustainable practice align with national goal of energy security and global climate obligation. Hydroelectric projects play a vital role in balancing energy needs with environmental sustainability. Malaysia's proactive approach in adopting new technology position hydroelectric power as a key player in the transition to a cleaner, more sustainable energy future. Ongoing, investment in research and development, along with conscientious project management, posed to further enhance hydroelectric power contribution to Malaysia's stable and environmental friendly energy landscape. Okay, that's all.